Alright guys, today we're going to talk about ellipses, which is our next conic section. If you remember, this is the one where if we cut the cone, instead of cutting it horizontally, we cut it at an angle, we end up with this like elongated circle thing. That's called an ellipse. And so that's what we're going to look at today, is ellipses, and what those are, and how to come up with the equations of them. So first off, how do we get this geometric shape? How do we get this ellipse to come up? So the definition of an ellipse is a set of all points whose sum of distances from two fixed points, which we call the foci, that's just the plural of focus. So focus is one, foci is more than one, is constant. So the way we create this shape is if we have our two foci right here and right here. So we've got a focus there, we've got a focus over here. And then here's our center of this. And if I pick any random point on this ellipse and take the distance from that point to here and the distance from that point to here, add the two together, I get the same answer no matter what point I pick on the ellipse. So if I go from here, add that length and that length, then I pick another point, say here instead, add that length and that length, I still get the same answer. So that's how we create this shape, two focal points, and the distance, the sums of distances from those two focal points is always the same. Now there's a lot of terminology that's going to happen on this picture of an ellipse right here. There's quite a few things we need to figure out. So I'm going to put in some different lines and segments and such into this picture. Now, the very first thing that we need to put in is our axes. Every ellipse has two axes. We're going to have the longer one and the shorter one, basically. If these were exactly the same length, this would not really be an ellipse as much as it was a circle then at that point. And so we're going to have a longer axis, which we're going to call the major axis. And then we're also going to have a shorter axis that we're going to call the minor axis. So we've got our longer axis, major axis, shorter axis, the minor axis. And the ends of the major axis, where it hits the ellipse, we call those points the vertices. So we've got one vertex there, we've got another vertex over here. So there's a vertex, vertex. And then these places where the minor axis hits, our book doesn't actually name these, but I like to give these a name because they're kind of an important point. We call these things the co-vertices. So that's a co-vertex. Here's the other co-vertex. And then we see we have the focus, another focus. The center is just right where the two axes meet, right in the center of the ellipse. There's a relationship between all these different lengths. We're going to come up with variables to represent some of these lengths that happen in this. And so the distance from the center to the vertex, so we're talking this distance right here, is A. We'll use the variable A to represent distance from center to vertex. We can also do the distance from the center to the co-vertex. So that would be this distance right here. We're going to call that distance the variable B. And then we could also find the distance from the center to the focus. That distance right there, we're going to call the variable C. Now something to note here, I'm calling this one A, but this is also A. Remember, an ellipse is completely symmetric, and so if I say distance from center to vertex is A, that means it's A here and A here, which means the length of the major axis is actually 2A. The length of the minor axis, you have B here, so the length of the minor axis is actually 2B. All right, so there's our terminology we need to get down. Now, this next thing is a really important formula that goes along with this. You notice B and C are shorter, and they're close to the same length in this, but I don't want you to think they have to be. B and C don't have to be the same length, but they do both have to be shorter than A. And tomorrow I'm going to show you guys why this relationship works. It is just too much to do today to get it all in here. So we've got B and C as the shorter ones, A is the longer one. If I would take A and move this length right up here, what we actually have is a right triangle with B and C as the legs, and then A is the hypotenuse, which means it's the Pythagorean theorem, but it's a messed up version of the Pythagorean theorem, where A is the hypotenuse. And so what we get out of this is we get something that looks like this. We get B squared plus C squared equals A squared. That is a relationship that's always true between B, C, and A, between those lengths of the pieces of this ellipse. And so if you're ever stuck on a problem, you're like, well, how do I know that? This is probably the answer. So keep that in mind. That's a very important little piece of information. All right, so there's what it looks like. Well, what's the equation of an ellipse? Let's see if we can figure this out. Now, if you really want a proof of where this comes from, it's some distance formula stuff, and I didn't want to go through it since we're not at school and we have a little less time. I didn't want to make a video that was like a half hour long. So if you want to look at that, it is in your book on the reference pages that I'll put on the Google Classroom. But the standard equation of ellipse with center HK looks like this. There's two options. Just like there was with a parabola, we have two different options based on what's happening with it. And we're still going to have the h and k part. So we're going to have x minus h, the quantity squared, over a squared, plus y minus k, the quantity squared over b squared, equals 1. Now, if the formula looks like this, if the equation looks like this, then this would be a horizontal major axis. Basically, what I have going on in that picture would be an equation that looks like this. Do you notice it's stretched out more horizontally? That means it would look like this particular example. And really, the only difference between these two is going to be the position of A and B. So our vertical major axis one, our other option basically, is this. Y minus k, the quantity squared, over A squared, plus x minus h, the quantity squared, over b squared, again equals 1. This would have a vertical major axis. I want to make sure you hear this part because this is important. The order of these two terms is completely irrelevant. So I could switch these two, and as long as A was under the y, it wouldn't matter. It would still be a vertical major axis. And so I know I put the y first on this one, but it's completely interchangeable for the order. Here's what always has to happen. A is always bigger than B. Really, here's what it boils down to. Whichever variable has the bigger number under it, the ellipse is going to be stretched out more that direction. So if the bigger number is under the y, it's going to be stretched out more in the direction of y, and therefore a vertical major axis. If the bigger number is under the x, it's stretched out more in the x direction, so therefore a horizontal major axis. So there's our big formulas we're going to be using to find this. And remember that h and k in this represent the coordinates of that center point of the ellipse. So there's the basics. There's the background information. Let's see if we can get to actually doing a problem that has to do with this now. So I have a couple that we're going to try to look at here. First one, I want to try to graph an ellipse. And I have the equation here. So we've already got the equation in standard form. We're going to try to find the center, the vertices, co-vertices, and the foci of this, and then draw a picture of it based on all that information. So very first place we should start is, where's the center of this thing? So remember, this is HK, and remember, just like the parabolas we just finished doing, this is minus in the standard equation, which means x minus 3 means the x-coordinate of the center is actually a positive 3. Y plus 1 means the y-coordinate of the center is a negative 1. So I'm going to go ahead and plot that point. We've got 3, negative 1. There's the center of this ellipse. All right, let's see if we can go from there and find some other information. Something else I'd like to think about is this going to be a vertical major axis or a horizontal major axis? Now, from what we just discussed, we're just looking for which variable has the bigger number under it. That's the y. which means this is going to be stretched out more vertically than it is horizontally. So it's going to have a vertical major axis. So that means this number right here is a squared. So a squared equals 9. So therefore, a is 3, just taking the square root of both sides. Now you might say a is plus or minus 3, but we're just talking distance, right? A represents a distance from center to vertex, and we're actually going to go both directions, so we're going to go plus and minus in the end. So if that's the case, really the amount we want to go up and down is just under y, take the square root of that number. That's how far we want to go up and down. And so to find the coordinates of the vertices, since that's 9 and the square root of that's 3, I'm going to go up 1, 2, 3, and down 1, 2, 3. All right, so there's our vertices of this. All right, and the reason we knew we were going up and down 3 is because this is under the y, basically. Y is the up and down. Under the x, we've got a 4. Now that's the smaller, which means that's automatically the b. So b squared is 4, so just taking the square root, that means b is 2. And since that's under the x, I'm going to go that much in the x direction. So I'm going to go 1, 2, and 1, 2, each direction from the center. Remember, b is distance from the center to the co-vertices. And so I'm going to write down some of these points that we've just figured out. So that means we've got vertices at, we've got 1, negative 1, and we've also got right over here 5, negative 1. All right, we've got co-vertices at, let's see here. I did those backwards. That's co-vertices. All right, we've got vertices at, those are up and down. So we've got vertices at 3, 2, and we've got vertices at 3, negative 4. All right, we've got co-vertices at 1, negative 1, and then another one at 5, negative 1. All right, now the other part that we're supposed to find here, so we've got center, we've got vertices, we've got co-vertices, we're supposed to find the foci. Now the foci always lie along the major axis. We saw that on our first one that we drew. The foci always go right along the major axis. So if that's the case, I need to go up and down from the center, but what I don't know is, what is C? You notice C is nowhere in the standard equation. However, remember if we're talking about we're looking for something and we can't remember how to find that third thing, it probably comes back to that equation that we had a little bit ago where we said b squared plus c squared equals a squared. That's what we can use here to figure out C. So I've got B, I've got A. That means I should be able to find C. So B is 2, so I've got 2 squared plus C squared. A is 3, so I've got 3 squared. Now, if you notice something, you actually already have A squared and B squared, so if you want to just go ahead and put 4 and 9 in here, you could. So I've got 4 plus C squared equals 9. Subtract the 4 to the other side, I get C squared equals 5, which means C is the square root of 5. That doesn't come out to a super nice number, but that's okay. So I wanted to show you how to write something if it doesn't come out to this. So keep in mind what we want to do to get to the foci is we want to go this distance, the square root of 5, from the center. I want to go that far up and down because they're always on the major axis and that's vertical on this one. And so to say those points, here's what I'm going to do. I'm going to say, I'm just going to put it down here. The foci would be then, well, if I'm just going up or down from here, you notice the x isn't going to change. The x is 3 at the center. Nothing's going to change about that because we're going up and down. Now, we want to go up and down the square root of 5. Really common mistake here is just to put plus and minus the square root of 5. That's not correct because we're not starting at 0. You notice we're starting at negative 1. So from negative 1, I want to go up and down the square root of 5. So from this starting point that's already at negative 1 for the y, from there, I want to go up the square root of 5 and down the square root of 5, which the square root of 5 is just slightly under 2 1/4. And so if we wanted to graph this, I'm going to go up 1, 2, and then just a tiny bit more, right about there. And if I want to go down, I go down 1, 2, and just a tiny bit more. So right around there. Now the graphing on this, it can't be perfect because we have this irrational number that we're trying to plot. And then just going to go ahead and try to draw in the ellipse, and hopefully comes out something looking like an ellipse. And there we go. There's our ellipse that has that equation. All right, does that make sense how we got all those pieces? All right, let's try to do one more here. All right, so this one we've got some information here. We're trying to find the equation. We don't actually have to do a graph of this one. Our goal here is to find the equation. We'll do this just so we're separate from that. So if I want to find the equation of this ellipse, center is 4, negative 5. I've already got h and k then, basically. The focus is 4, negative 2. That's going to allow me to find c, because distance from center to focus is c. I've got the vertex is 4, negative 1. That's going to allow me to find a, because a represents distance from center to vertex. So let's see if we can put all this information in here. First thing I want to think about is this going to be a stretched out this way, a horizontal major axis ellipse, or is it going to be a stretched out this way, vertical major axis ellipse? So if I'm going from 4, negative 5 to 4, negative 2, do you notice what's changing here is the y values? So we're going up and down to get from one to the other. Now, if we're going up and down to get from one to the other, that means this has to have a vertical major axis. So you don't really have to plot this. You could if it helped you to see it, but it's really not necessary to draw a picture. And so since it has a vertical major axis, we know the bigger number a is going to be under the x. And so I'm going to start to write the equation with what we know. We know the beginning has to look like this. All right, this is a vertical major axis, so I need the smaller number under the x, so that's our b squared. We need our bigger number under the y, so that's our a squared, equals 1. All right, so let's see if we can fill in all the pieces here and figure out what a squared is, which we actually could figure that one out now, because distance from center to vertex. You notice from center to vertex, we went 4 units, negative 5 to negative 1. So we know a is 4. Center to vertex, we went 4 units. We also know c here, distance from center to focus, is negative 5 to negative 2. We went 3 units. What we don't know is b, and if I'm going to finish this equation, we need a squared and b squared, so we kind of need b to figure that out. And remember what we said a minute ago about that one relationship that's really important? Here it is again. We need to use this again, because in this case we know a, we know c. If I know any two of these, I could always find the third. And so we're going to put that information in here and see if we can figure that out. So I've got so far b squared, which we don't know, leave that as an unknown, plus c squared, so I'm going to say plus 3 squared, equals a squared, so equals 4 squared. So I've got b squared plus 9 equals 16. So I'm going to subtract the 9 to the other side, and when I do that, I get b squared equals 7. Now you might be tempted to solve for b and take the square root, but if you think about what we need for this question, what we need to fill in is b squared, right? So b squared is 7. Because if we took the square root, we just take the square root and then square it again to put it in there. And so our final equation, we're going to have x minus 4, the quantity squared. B squared goes under there. We just found out that's 7. So that's good for that part. And then plus y plus 5, the quantity squared, over a squared. A is 4, so a squared therefore is 16, equals 1. So there's the equation of an ellipse that has a center at 4, negative 5, has a vertex at 4, negative 1. We made the a 4 to make that happen. And then knowing that a is 4 and c is 3, that makes b squared be 7. So under that, to get to our co-vertices, it has to be a 7. All right, so there's the basics of an ellipse. We're going to do a little bit more with this tomorrow and a little more with some of the practical applications of what an ellipse does and how to draw them and things like that. And I also want to explain why this relationship is what it is and how that works. So more to come on ellipses tomorrow, but that should be good enough to get you a good start on this today.